Hello, everyone. Sorry I couldn't be here in person for this lesson. Um, and so hopefully you're able to follow along on this video. Um, and so as you go through this video, you should be taking notes and hitting pause whenever I tell you to hit pause, so that you can actually try out the examples that I have in the lesson. Um, so let's and also taking notes and writing down any questions you have so that you can email me with your questions or ask them to me in our next class. All right, so let's get started um, with the warm up. And so you want to try to write each transformation in terms of f of x. So that's like we've done a number of examples like this. Um, and so, first time, pause the video, try that out. And then once you've given it a try, you can resume to see the solution. Okay, so with this, it's going to be a good strategy to again, look at the reference points. So on the parent function, we've got a few different reference points like these here, this one on the end. You could also use a point like this one here. Um, and so looking at those reference points, in particular this one, we should be able to see that there was no translations that actually happened here because that point did not move in any of the transformed functions. So there's no translations or shifts that happened, and we should be able to tell that there was no reflections that happened either. So really, we're just trying to figure out what is happening in terms of the stretches. And so our first task with each of these is to determine what type of stretch it is. So is it a vertical stretch or is it a horizontal stretch? And so the way that we should be thinking is by thinking, are the x values being affected or are the y values being affected? So I'm going to go with start with the red one, and I'm going to identify one of my reference points. And I just really want to see what's happening to that reference point. And so if I look at that one there, um, then I see that it has the same x value, but a different y value compared to the reference point in the original parent function. And so that tells me that this must have been a vertical stretch because the y value is being affected. And so now I need to figure out by what factor. And so in our parent function, that reference point had a y value of 1. And now in my transformed function, it has a y value of 3. And so that tells us exactly what the factor is. And so in function notation, we're just going to write 3 times f of x. All right, let's go to the orange one. So we're going to do something very similar. This time I'm going to focus on this reference point here. And so once again, I see that it has the same x value, but a different y value. And so that again tells me that this must have been a vertical stretch. And so again, I need to know the factor. And so in the original parent function, that had a y value of 4. And in my new transformed function, it has a y value of 2. So the y value was halved. And so if we're writing in function notation, be 1/2 times f of x. All right, blue one. So once again, going to pick some reference points. I'm going to pick those there. And so now I see, okay, they have the same y value, but different x values now. So it must have been a horizontal stretch. And so parent function had an x value of 2. My transformed function has an x value of 8, which means, all right, the x values were being multiplied by 4. And so then writing in function notation, though, we have to remember that the transformations that happen inside of the parentheses are opposite. And so since the x value is being multiplied by 4, we're going to write f of 1/4 x. All right. So hopefully that was not too bad. That is the kind of thinking process that you should have with problems like this, thinking about um, are the reference points moving around? Are the x values being affected? Y values being affected? And so on. All right, let's get into the actual lesson now. And so this lesson is all about absolute value. And so we're going to start just with the simple definition of absolute value. Then we'll get into graphing absolute value functions. And then finally, looking at solving absolute value equations and inequalities. So let's get started. You should be taking notes as you go through this. Pause whenever you need to if you need to catch up on taking the notes. And so let's go. All right, so absolute value very basically is how far a number is away from 0. So it's measuring the distance of a value from 0. And so can distance be negative? No, it cannot. And so the absolute value will always have an output that is positive. And so, for example, if we consider this very simple absolute value equation, and we're trying to determine what could x be, well, we're trying to think of what numbers are 6 away from 0. And so that is -6 and +6. Both of those are 6 away from 0. And so those would be our two solutions. So with these absolute value equations, we are typically going to be getting two solutions because there are two directions on a number line. And so since we're measuring distance from 0, we could be either to the right of 0 in the positive side, or we could be to the left of 0 in the negative side. So again, typically we're going to be getting two solutions like this. And that's also made clear down here with the algebraic definition, again, reinforcing the fact that in an absolute value, there are typically going to be two solutions here. So absolute value of x can either be positive x or negative x. All right. So first skill that we're going to be going over is graphing, or how to graph the absolute value of a general function. So let's say I have a parabola like this. And so so that's my f of x. And let's say I am asked to graph the absolute value of this function. And so I'm going to be following these steps here. So first step is to keep the graph for f of x greater than or equals 0, or for when it is positive. So looking at my graph, I can see, well, this part and this part are both positive already. So I'm going to be keeping those parts exactly how they are. Now, second step is to take the part that is negative, so this part, and we want to reflect it over the x-axis. So that's what I'm going to do. Just that part I'm going to reflect over the x-axis. So this point, for example, will go up here, and then I'm going to try and copy the shape as best as I can. All right, so then my full absolute value function is now everything in green. So we've got this part here, which was already positive. Then we've got the negative part that we reflected, and then this part here, which was also already positive. So that's how we will be graphing the absolute value of a function, just following those three simple steps, which the third step we don't even really need to think about. It's just that the points on the x-axis remain the same. So like this point and this point remain the same. Okay, so this actually leads to why the graph of y equals absolute value of x looks like a V. So really it's coming from the fact that if we originally consider the graph of y equals x, well, that line looks like this. It's got a slope of 1, y-intercept of 0. And so if we just take y equals x and now we want to do like what we did up here, following those steps, well, we keep the positive part, so we keep this part. Then we want to reflect the negative part over the x-axis. And so when we do that, that creates this part here. And so that is the graph of absolute value of x, and that's why it looks like a V like that. All right, so hopefully that generally makes sense. And again, it's if we look at it like on a coordinate basis, so like for example, this coordinate here, which is, let's say that's -2, -2. Well, if we have the function f of x equals absolute value of x, and we're plugging in -2, well, absolute value of -2 is 2. And so that means this point is going to become -2, +2. And so really we're doing that for every single point that's in the negative section. And that's again why it creates that V-shaped graph. All right, so let's do a little practice with this. So want you to pause the video here and you're gonna copy the graph and try to draw the absolute value of this graph. So pause the video, try it out. Okay, so you might have noticed that I had already labeled these 2 points down here. And so that can be quite helpful when we're doing something like this. So first step, I'm going to keep this part since that part is already positive. And then with those 2 points that I've identified, I'm going to reflect them over the x-axis. So like this one here, -4, -5 is going to turn into -4, +5. Same thing here. At this point, 2, -5 is going to turn into 2, +5. All right, and so then at this point, we want to kind of try to copy the shape as best as we can. And so there we go. That would be now, that W shape is now the absolute value graph of this function. All right, let's try it again. Another example, very similar, with a different type of function. So again, you are wanting to graph the absolute value of this function. So once again, pause the video. You don't have to be as precise with this one as you did with the last one. So just copy the general shape and then graph the absolute value. So pause now, try it out. Okay, so following my steps, this part positive, this part positive, so those are going to stay the same. And then this part and this part need to be reflected. So I'm just gonna try to do my best in terms of copying that. So that one would look like that. And then this would look like this. And so put the whole thing in blue so that we can see. And so now what I have in blue would be the absolute value graph of that. Hopefully that's not too bad. It's just following those simple steps and just using the idea that absolute value is measuring the distance of each point away from zero. And so it's turning any negative y values into a positive y value. All right, so that's enough of graphing. And so now we're going to move into the next part of the lesson, which is on solving absolute value equations and inequalities. And so first we're going to go over these three general scenarios and how we are going to handle each of those scenarios. So, and with each one, we're going to try to visualize this on a number line. So starting with the equation here. So absolute value of x equals a. So if we're thinking on a number line, what this is saying is that the distance of x from 0 is a. So that means that x could either be negative a or x could be positive a. So when we have a scenario like this, our first step is going to be to set up to the two possible equations. So the problems you're going to see, there's going to be something more complex inside of the absolute value besides x. So if we take a peek at the next example, something like this. And so our first step with this example is going to be to say, okay, 2x plus 7 is either going to be negative 13 or 2x plus 7 is going to be positive 13. And then we would just solve those two equations separately. So that's how we handle an equation. And so now let's look at how do we handle an inequality. And so there's two inequalities, two types of inequalities here. Or situations. Or the first situation is when we're looking at less than, and then the second situation is greater than. So starting with the less than situation. Again, if we're imagining this on a number line, and we're thinking about what this is saying that the distance of x to 0 is less than a. So if the distance is less than a, that means that x is going to be somewhere in between negative a and positive a. And so this creates an and inequality. Um, so because if x was a number bigger than a, well, then that's has a distance of more than a away from 0, and so that's not going to be valid here. Um, and so when we have the less than situation, it creates an and inequality, and so we would set up the and inequality and then solve from there. All right, finally, we have the third situation, which is when it's greater than some value. And so again, considering the number line. So then if x is now greater than a, absolute value of x is greater than a, that's saying that the distance of x to 0 is greater than a. So that means it's more than a units away from 0. So it's got to either be greater than a or less than negative a. So this is leading to an or inequality. All right, so those are the three scenarios that you will be encountering here, and that's how we are going to handle each one of those situations. And so in terms of remembering like the between these two scenarios, so whether you should make an and inequality or an or inequality, I do have a little trick for you to remember if you want, which is something my ninth grade teacher actually taught me, which is less than and greater. So if it's a less than symbol, it creates an and inequality. If it's a greater than symbol, it creates an or inequality. It's a bit of a silly trick, but it could be helpful in terms of remembering the difference. Okay, so let's just practice that and see what problems like that look like. So going back to this one, it was an equation. And so our first step was, again, to create the two branches, the negative branch and the positive branch. And so we've done that already. And so now all that's left is just solving these two equations separately. And that should be pretty easy. We're going to start by subtracting 7 on both sides. And then we're dividing by 2, dividing by 2, dividing by 2. And so we get x equals negative 10 or x equals 3. And those would be our two solutions. Remember, we're usually going to get two solutions here. All right, so I want you to try that out on your own. So once again, pause the video and try solving each of these absolute value equations. All right, so starting with A, we're first gonna set up our two equations. So it's gonna equal negative 7 or positive 7. Then subtract 3, subtract 3. And divide by 2, divide by 2. And so we get x equals negative 5 or x equals 2. Easy peasy. The other one. So this was actually a bit of a critical thinking question. And so if we think about this, what this is saying is we have an absolute value equaling a negative number. That is not possible. An absolute value cannot equal a negative. So what do we write here? We write no solution. So maybe you noticed that, maybe you didn't, but there you go. So we should keep that in mind and be looking out for that. Before we move on, a bit of good news for you. This scenario of like absolute value equaling just a single number, you are not going to be experiencing an equation that is more complex than that, where you have to solve by hand. The ones that are going to be more complex with that than that, that'll be on like the calculator section. All right, so let's now do a little practice with the inequalities. And so your first task is deciding whether it's an and inequality or an or inequality. And so remember the little trick, greater or less than. So once again, pause the video, decide if it's or and, set up your inequalities and solve. All right, so first one, part A, that is a less than symbol, which means we want to set up an and inequality. And so that's what I'm going to do. And so this is how we would set it up, which you can set it up like this, or if you're not comfortable with that, you could also set it up like this. So like two separate inequalities. So 2x minus 1 is either going to be greater than negative 3, and 2x minus 1 needs to be less than 3. And then you can go solve them individually. But I want to show you like how we can just do this, solve something like this. So when we have something like this, what we do to the middle, we have to do to both of the sides. So what I mean by that is like, if I add 1 here, I need to add 1 here and add 1 here. And so that's negative 2 less than 2x less than 4. And so then similarly, divide by 2, divide by 2, divide by 2. And so then we get this as our final answer. All right, part B. So that's greater than. And so that means we are setting up an or inequality. And so when we're doing that, the positive version is literally the same thing, just without the absolute value sign. Whereas the negative version, we are going to flip the inequality sign and make the 5 negative. And so once we've done that, now it's just a matter of solving each one separately. So we're going to subtract 4. And then we want to divide or multiply by negative 1 to get x by itself. However, when you are solving an inequality and you either multiply or divide both sides of the inequality by a negative number, you have to flip the inequality sign. So this turns into this, and this turns into this. And so this would be our final answer. X has to either be greater than or equal to 9 or less than or equal to negative 1. All right, hopefully that's not too bad. Like I said, you're not going to be expected to do anything more complex than this by hand. So that leads us. Oh, we've got this example first. All right. So you might actually recognize this question from a quiz we had in Unit 1. Uh, and so want to go over it because it does involve absolute value. So we want to consider the infinite geometric sequence, this, and we want to determine what values of x make the series converge. And so first thing we need to do is remember, what does it mean to converge as opposed to diverge? So hopefully remember, converge means that the terms are getting smaller and smaller and smaller, and so it's approaching one single number. Whereas diverge is when the terms get bigger and bigger and bigger, and that approaches infinity. And so for a series to converge, we needed R, the common ratio, to be between +1 and -1. Or in other words, we need the absolute value of the common ratio to be less than 1. And so, okay, now that we've established that, this is what we want. We need the common ratio, the absolute value, to be less than 1. And so now we need to figure out, well, what is the common ratio in this series? So we want to think, what are we multiplying each term by to get to the next term? Well, hopefully we can see that just by looking at the first two terms. Like, what do you have to multiply by 1 to get 3x over 5? Well, you multiply by 3x over 5. Okay, so now, if we want to answer the question, that means we need to solve this equation. We want the absolute value of our common ratio to be less than 1. All right, so it is a less than inequality, which means less than. So we're making an and inequality. And so we have 3x plus 5 less than 1, greater than -1. And now we solve. So first thing we're going to do is multiply each side by 5 to get rid of that fraction. And now we're going to divide each side by 3, and this is going to give us our final answer. So I just, again, wanted to revisit that so that we can do a little refreshing of our memories on series, and because it does involve an absolute value. Okay, we got one more thing to cover, which is using our calculators to solve. And so here we can see, all right, now we're seeing some more complex absolute value equations and inequalities, and so now we're gonna use our calculators to solve that. So take a moment to actually get your calculator out, and I'm going to now show you how we're gonna do this. All right, so we're going to be doing this using the graph, and that is because, as we've seen, these absolute value equations give us multiple solutions, which So we don't want to be using the equation solver because that only ever gives us one solution. So like if we had this equation here, absolute value of x plus 3 equals 5, and we ask it to solve, well, it gives us one of the answers, but there is another answer. And so this is not going to be what we want to do. We want to use the graph to solve. All right, so using the graph, what we're going to be doing is we're going to be putting absolute value of x plus 1, or the left side, in y1, and we're going to be putting the right side in y2. So how do we type in an absolute value? First, we press the option button. Then we press F5 for numeric, and then F1 for abs. Getting some abs here. We do that, and then type in x plus 1. So once again, that was option, F5 for numeric, and F1 for abs. All right, so that's my y1. In my y2, I'm typing in x over 2 plus 2. Okay, and then we draw. You might need to make sure you're in a standard viewing window. If you're not, press F3 for window, F3 again for standard, and that will bring you to a standard viewing window. All right, so we are looking for when these two things equal each other, which means we are looking for when they are intersecting with each other. So we're going to press F5 for gsolve, F5 again for intersect, and there you go. There is our first solution, x equals -2. We don't care about the y value because looking at the original equation, it does not involve a y. We only care about the x. So x equals -2 is our first solution. Press the right arrow, and x equals +2 is our other solution. So those are our two solutions. So let's write those down. X equals 2 or -2. All right, next we want to do part B. So let's go back to y equals. We're going to keep absolute value of x plus 1 and y1 because that's still the left side of the inequality. But now in y2, I want to type in the square root of x cubed plus 2. Now, this is going to take an extra layer of thinking because it's an inequality now instead of an equation. So let's look at the graph. All right, so there's our graph. And so really we are looking for when is the absolute value of x plus 1 greater than the square root of x cubed plus 2. So we're graphically looking for when is the blue graph above the red graph. That's how we would know that the absolute value is greater than the square root. So I kind of want to zoom in. This is not really detailed enough. So I'm going to press F2 for zoom, F3 for in, and then you press enter. It's still not quite zoomed in enough, so I'm going to do that again. And then I'm going to use the arrows so that I can see this part. And I'm doing this because I see right here, this part is where the blue line is above the red line. And so that is going to actually be my solutions here. So I want to see between what two x values is this going on. That's when the absolute value is greater than this square root function. So I still need to find the intersection point. So I'm going to still go to F5 for gsolve, F5 again for intersect. I don't really care about that intersection there. So I'm going to hit my right arrow. All right, there's my first x value, 0.445. So I know now that x needs to be greater than 0.445 and hit the right arrow, and less than 1.80. And so that is going to be my full solution there. And again, that is just looking at the graph and seeing when is the absolute value greater than the other thing. And that is between those two x values. Hopefully that makes sense. If not, I can help you out in our next class. All right. So that's it for the actual lesson. However, I went over this with the other class, and so I'll go over it briefly with you. Which this is the part of the subject report for our course from the IB exams that happened in May of this year. And so I really want to point out, like, what are the actual grade boundaries for this course. So first, your IB score for this course is made up of three things. It's made up of the internal assessment, the IA. This is the going to be the research paper that you're going to be writing, or the exploration that you're going to be doing for this class, which I'll be introducing to you at the end of the semester. That's out of 20 points, and so these boundaries do not change from year to year. These are the same boundaries every year for the IA. And then you have your two exam papers, the no calculator and the calculator exam papers. And so those are each out of 80 marks. And so let's see what it takes to get each of these scores. So let's focus on paper 1. So to get a 7, you needed to get at least 51 out of 80 marks, which is a whopping 63.75%. Then to get a 6, you need at least 40 out of 80 marks, so that's 50%. So this is why most everyone on the last test got a 6 or a 7, because it's not so difficult. Well, we have to consider some other things. Let's look at the other percentages, and then we'll consider a couple other things. So for a 5, you needed 29 out of 80 marks, which was 36.25%. For a 4, you needed at least 18 out of 80 marks, which is 22.5%. And to get a 3, which is the minimum you need to pass, you needed 11 out of 80 marks, which is a whopping 13.75%. So this might seem a little crazy for you. Hopefully it does give you a little bit of confidence. But we do need to consider a few things, which are that this is the IB exam, and so it's covering 2 years worth of material, whereas your unit tests are only covering individual units. And you have to consider that there is a variety of difficulties in the questions, and so you could get a very challenging question that's worth 8 marks, and if you can't do anything with that challenging question, well, that's already minus 10% on that paper, since it's out of 80 marks. So this is something to keep in mind. But again, I hope this gives you a little confidence and a little context on, like, how you can think about your grade on tests and quizzes compared to the IB score. All right, that's all I have to say. Hopefully, that was not too bad. You took some notes, and if you have any questions, please feel free to email me or ask them the next time we meet each other, which will be on Monday. Have a good weekend.